Our next speaker is Sergei Bulaev, and the talk of his speech is Next Best Action. Wow. Probably that's because next best action is quite difficult to pronounce. So even it's hard for the sound system here. Maximizing customer value. Sergei is working for EPAM Systems, and welcome to our stage, Sergei.
Thank you.
Have a nice day.
Thank you very much. So, next best action and how to maximize customer value. This is the topic of today's speech. And, oh, that is not mine. Now it's mine. So, it's a couple of words about myself. Strategic management education, master of data science, more than 6 years experience in data science field. And the main areas of working is banking and retail. And currently I'm a senior data scientist at EPAM Systems. So I would like to kickstart off this session with this. 78% of CEOs are now banking on marketing leaders to drive the growth. But we can drive the growth only if we can measure it. And this is an important thing, and performance metrics will help us with it. The high-level basic formula, the profit is equal to revenue minus costs. Pretty much we can understand what's going on in the business by this formula, and a good point as a data scientist can influence on each component of this formula. Let's derive revenue for these components. So the revenue comes from revenue from the services and revenue from the products. If we look at the products, its revenue comes from purchase frequency, number of customers, and average order value. These components are integral parts of consisting the revenue from the product. If we derive average order value, it will consist of average product price, average number of products in an order. If we just multiply these two components, we'll get the average order value. And average number of products in an order consists of cross-sell activities, upsell activities, different number of products added from search, from recommendation, and from marketing campaigns. So, and in our talk, I would like to stop a little bit for marketing campaigns, because this is the main topic for today. And let's think about what kind of marketing campaigns could be and how the revenue from marketing campaigns come from. So the revenue per marketing campaigns come from average order value again and number of buyers. Then average order value comes from average price and number of goods in an order. And number of buyers, they comes from number of visitors on our website. Then website and mobile application, these are all our sources. Maybe it is more sources we have. And let's think about a simple little example of some marketing campaign that we can run. So the average price is about 5K forints, number of goods 2, it's just an average. Then the average order value will be 10K. Now let's look at the visitor side. We have 100,000 visitors on our website, in total, I mean, and the website 70% and the mobile application 30%. Now we have an integral component like a conversion rate, because not all our visitors becomes our clients and customers. Now we have 3K buyers, and by multiplying these two components like average order value and number of buyers, we'll see the revenue from the product, from marketing campaign actually. Let's think about another example. Buy 2 goods and get a 50% discount on the third product. So now our average price will decrease because of a discount. Number of goods will be increased from 2 to 3, and the average order value will be 12K. Reasonable. Now let's look at the number of visitors. So we see that number of visitors decreased from 100K to 75, and the website and mobile application as well. But the conversion rate increased from 3% to 4%. And yeah, the total revenue will be multiplying all these components as in previous result. How it happened that conversion rate increased and the number of visitors decreased? So this is an application of our machine learning models, and this is how basically all this tree of metrics is how we can derive our metrics practically on almost all marketing campaigns at all. Yeah, for sure there will be some adjustments, some additional components, but the main thing, the main structure will be anyway the same. But here's the question. What if we send the communication to all our customers, but what if the customer can buy all three products by the full price? Do we need to send him this communication? Probably not, just because we are losing money for this client. And this is how we also can model this behavior of the clients. And here I would like to talk that offers are not more just, the offers are more than just discounts. And basically it could be abandoned cart, coming back to abandoned cart. So you put something in the cart on the website, and then you just didn't buy for now, and you will get the email, hey, come back to us, you have something in the cart. So we have cross-sell, upsell, service, gifts, reactivation things, onboarding programs, event marketing, bundle deals, so many marketing activities. Why do we have so much? And this is just several of them. There are hundreds of different marketing campaigns. And this is just because acquiring a new customer is 5 to 25 times more expensive than retain the customer, than retain the existing customer, than develop the current customer. And we are moving from product perspective. When we have a product and marketers have to find some proper audience for it, or they have an offer for the audience, and they need to find something from their customer base somehow, and maybe some communication channel, maybe just select from all the database. And now we are moving to I have a person, to a customer perspective. And here the customer profile defines what offer the customer receives. And this is reasonable because if we just compare 4 different types of communication, basic communication, when we just created something, create some message to the customers and send them. Compared to the segmented approach, when we derive segments, for example, we can use RFM segmentation, recency frequency monitoring. And based on that, we can derive some customer segments. Or if we divide all these customer segments into micro segments and compare it to the personal approach. And according to Adobe research, the conversion rate from personal or one-on-one conversation is 10 times higher than basic emails, basic messages to the customers, and 10% higher than micro segments. And this is reasonable. And you can ask, why do we need to do many things to build a personal approach, build machine learning models, hire a lot of people, develop our databases, and so on, while we can just do microsegmentation. And microsegmentation is a great thing, very cool thing, and it works for a lot of years. And the only one thing here, suppose we have 30 different segments, a lot. And we need to create some new marketing campaigns for each of these segments on a, for example, weekly basis or monthly basis. And suppose we have 3 marketing campaigns for each segment. So it will be already 100 different marketing campaigns, and we need to manage it somehow, and it's quite difficult. With the personal approach, using machine learning, it's more or less automated, and marketing leaders, they can think of being creative rather than do manual things. How to build such a personalization? This is a good question because it sounds reasonable and sounds to be effective. And now let's embark our journey and build some bridge between marketing and intelligence. And this is the very well-known, time-tested 4P framework in marketing: product, price, promotion, place. And these 4 pillars have been a bedrock for marketing strategies for decades. For sure, now it's expanded for 7P, 7S, and so other framework. But this is the core. Without product, we can build a solution. Without price, for sure. Without promotion, yes. And we need to communicate with customers somehow. So the product dimension explores the fundamental attributes of our offerings. How we can build a product, what features do they have, what features set them apart of a crowded marketplace, and how we can bundle our product with other products in order to build irresistible value. Then the price is another integral component. This is the delicate art of pricing strategy with a dance between with a dance between affordability and the perceived value by the customer, and punctuated by well-timed discounts. Promotion, this is the heart of our marketing. This is the craft of compelling narrative that resonate with our target audience. And the place, this is our where channel when we talk with our clients in a very convenient for them way. Someone prefers person communication, someone prefers texting communication, and this is place component answers for this question. And now let's have a bridge between marketing and machine learning framework. And we developed a framework, I called it Fortune, segmentation, personalization, recommendation and optimization. And these 4 pillars are about the marketing in data science in marketing field. So segmentation is about how we divide our customer base into meaningful segments to resonate with our customers and to communicate with them. Recommendation, this is about how to make our offers personal to each client, how to advise them particular products that they need. Personalization, this is the art of predictive analytics, and when we can think of the likelihood of doing some action of the person, and where we know not only what customer have been done in previous, but what he is likely to, what they are likely to do in the future. And optimization, this is about how we optimize our time, how we optimize our channel, how we make these communications be convenient for the customer. And all these components are basically next best action. If we trying to categorize all these components into something meaningful segments, we'll see that the central stage takes classification models. This is about predicting likelihood, cross-sell, promo optimization, optimal channel. The personalization systems could be offline, online, and the other part is clustering. It could be manual, like I said before, RFM segmentation, recency, frequency monitor. Recency about how long with the customer with us. Monitor is about how much money did he spend, and what else? RFM. And frequency is how often he does or they does their purchases. And now let's have a look closer to classification models. Now this is the art of different models that have different names, like lookalike modeling, uplift modeling, and response modeling. These 3 things we will discover later. And about recommendation systems, it's about hybrid models and collaborative filtering. There are some other names for sure, but these are main components of this in this field. Now, suppose we've built some models, lookalike models, response or uplift models. Even we build recommendation systems. What next? Suppose we picture this. We built 10 lookalike models on different target actions. We built 20 response models on different marketing campaigns. We built several uplift models about some discounts, about some channels, communication channels, which customer will prefer, and some recommendation systems for for categories, for regions, for something else. And now this question, how do we communicate with the customer to make it effective? The answer is not obvious, but it's very complicated. And let's have a look at 3 components or 3 main channels how we can communicate with customers. So we can communicate via email, SMS, push, WhatsApp, doesn't matter what customer prefers, basically. We can communicate in person if we have a person in a loop. Basically, it could be a sales representative, it could be an assistant, or some people who are likely to communicate with the customer in one-on-one. And it could be a personal context advertising through the social networks, for example, or in Google search. And if you look at the social networks, just picture this. You're scrolling your feed in Facebook, and you see one advertisement, for example, PlayStation, new PlayStation, and you like play FIFA, for example. Now you're scrolling down, you see the same advertising. You think that you see the same advertising, but it could be adjusted by different factors. The text could be different. The pictures on this advertising could be different. The colors would be different. And this is where we see the magic of some restrictions, some not restrictions, but some boundaries. For example, for the first channel, we have one attempt and one product because we want to engage the customer, but we don't want to overwhelm them with the communication. We cannot send the communication every day. Hey, look at this picture, buy this product, buy this product, buy this product. No, we have one product, one attempt, let's say one attempt in a month. In a person, the same way, but we have many products that we can offer. For example, I'm a sales representative, I'm talking to the customer, and I can advise him one product, look at this, let's say 5 products I can explore. And about social networks, we have a lot of attempts, because every time you scroll in the feed, every time you will see you can see the different products, and you can see the different tries to interact you. And here the art of optimization models comes into the stage. For ranking models could be applied for basic things like in-person communications or email or SMS, because we just need to rank our products, and based on some formula, based on ranking model, we will send top 1 communication or top 2 or top 3. And some other very, let's say, complicated models like multi-arm bandits, Markov chains, or reinforcement learning, we can use for social advertising and social networks. Just because we have a lot of feedback loop, because the customer have seen the advertising, then we can immediately get the positive or negative answer from the customer. And because we have a lot of interactions, we have a lot of data, and that's why we can multi-arm bandits, how they work. We have let's say a hand, we just put a hand, and again and again and again and again. You have seen these names of these types of models, lookalike, response, and uplift many times already. And what do they have in common? They are all classification models, as we've seen before. And what does it mean for us as data scientists and who will do some modeling part? It means that they have a lot of in common, different preprocessing steps, different modeling steps. But here's the thing that I want to specifically talk about, because this is the main thing, is the target. This is the main difference between all these types of the models. And for lookalike modeling, the target would be probability of a target action based on similarity. We will talk about some examples later, but the response modeling is about probability of target action given communication. And uplift models, it's the probability of target action given communication minus probability of target action without communication. What does it mean, basically? We, in uplift modeling, we would like to know, do we need to give a promotion to the customer? Do we need to give him a discount? Maybe he is ready, or they are ready to buy something for the full price. Why do we need to spend money for them? And this is the question that I want to talk about later. And let's play some little game. Let's think about these quotes and think about what model it is. So find the customers beyond our existing segment. Provide recommendation for expanding our reach while maintaining relevance. What kind of model is it? Lookalike, response, or uplift? Any guesses? It's lookalike modeling. We are looking for some customers that are existing in some segment, and we want to find the most similar customers to this segment. And by this action, we will expand it. The second, maximize the impact of campaign by targeting individuals who are likely to respond positively. So basically, we can see the, let's say, target word, respond, and this is a response model. Choose customers that will purchase only if they receive a discount, and separate them from that customers who will purchase without an offer. So it's basically about uplift modeling, because we want to give the discount only to those customers who will not buy without a discount. And one more. Predict the likelihood of customer taking specific action, such as making purchase, subscribing, or engaging with the campaign. So basically, this is lookalike modeling when we have a specific target, subscribing some target action. And how to build such a pipeline? Let's look at the standard machine learning process. It has some data preprocessing, machine learning, and some A/B testing, because this is an essential part in our work to understand whether our models work or not, and some productionalizing steps. And the average time to market of such a combination is about 2 months. Depends for sure about the data, about the environment, about the nature of the company. But anyway, it's about 2 months. What we can think about? We can think first about data pipeline, because it matters. Picture this. We have 5 data scientists in a team, and they are doing their models. They are using PySpark, SQL, Snowflake. So the instruments that they get used to through their experience. And they are going to different tables. They try to get some data. Some of them doing some pre-processing steps right in SQL. Some doing pre-processing in PySpark. Some of them download the data right into Python and do all transformations right in the Python. And here we can think of different very common things from this data scientist. They collect the same features, maybe in a different way, but they use the same features. And this is the thing that we can think of, and try to understand what problems and what causes we have. So the first, let's say, problem or issue of this method, that you spend the time for developing of the feature, which has already been created by another colleague. This is super typical situation. The second, a colleague come to you with a question, hey, do you have a calculation of such a factor? Yes, take this code. And then the colleague said, okay, I've seen the code, it doesn't suit to my pipeline, so I decided to rewrite it. And the third one, you did some calculation of the factor, which is cool for the model. Maybe it would be the top 1 priority, top 1 feature based on feature importance, but it's too heavy to calculate into production. So you need to get rid of it. And what kind of data can we put into what can we use basically? We can think of fundamental factors. For sure, everything depends on GDPR and private and how we can use the data. But anyway, fundamental factors like in banking, these factors are all of this are important. Then we can think of experimental insights. This is how basically we communicate, how we communicate with the customer and how they react. So it's about customer satisfaction index, NPS, Net Promoter Score, churn rate, usage frequency, time since last purchase, and so on. The other component is behavioral data. So it's basically how the customer behaves. What is his purchase frequency? What is sequence of his action? What he does on the website? What he does on in mobile application? And the last one, it's financial outcomes. It's not drivers of the. Usually it's not the drivers of the model, but also we can use these components as factors in machine learning, such as profit margin, CLV, ROI, average order value. All these components are very important, and sometimes they are good for the model, sometimes not. Depends on the model and depends on the feature importance in the end. And all of these factors we can put in a feature store. Feature store could be also completed by our favorite DF group by or DF make a pivot table. And picture this, we have 4, let's say, dimensions: period, amount, dimension, and aggregation. And by doing such an aggregations, let's say we take the 3 months window, we take how much money the person spent in this three months window. We have different dimensions like brand, category, region, day of week, months, online channel, offline channel, and we have some aggregation like sum, average, mean, and so on and so forth. And suppose we did this group by function, and on this approach, so for sure it's not group by, it's group by. Basically for analytics, we can make a pivot table to make these columns, to get these columns. But if we do this, we picture this. We have 6 brands, 6 aggregations, and 6 periods. So we already have 200 features. It's more than enough to build some kind of model. And if we do it by all these factors, we will have thousands of features. For sure, at the beginning, it might sound like crazy because we have 2,000 features. So what if we have 10 million clients? No, but we have some techniques how to eliminate most of these features, right? At least based on missing values. What are pros and cons of feature store? The first pros is no discrepancies between the models. If your feature calls how much money customers spend for 3 months, it will be the same meaning for each of the models, for each of the data scientists, and it will be very clear for business managers as well. They understand what do you mean. Then reusability. Everyone can reuse all these features, all these recalculations. Same methodology for prototyping and training. Do you remember that last disadvantage of separated approach, that in training the feature is good, in production it's too heavy. This is about this. Discoverability, you can find all these features in the same place. So there are one single or couple of single not couple of single for sure, couple of tables that you are joining together, and you will get all the features. And one more thing, very important, by the way, data scientists usually are not only working on the models, they are developing features. And by creating a feature store, you can divide your work between data scientists. Some people are doing some job with the preparation data, trying new features, and some doing the modeling part. And usually when we make a feature store, everything will be very well documented, which is very important for us. What are drawbacks? The first drawback is that teams and analysts are dependent to each other heavily, really heavily. It's not convenient to make any changes for individual needs. So, for example, my team needs to have another calculation of the factor. Okay, but in feature store we cannot put it. You need to collect it manually. And basically, some manual features, additional features, it's a normal thing when we need to upgrade our model to create such a new factor. We try it in the model, we try to create it by hands, and then apply the model. Okay, now the process is a little bit more clear. All data scientists are going to feature store that collected from different tables. And by this action, we actually can decrease the time to market from 2 months to 1 and 1.5 months. Now, let's look at the machine learning pipeline, how we can optimize it. Because do you remember previously that lookalike, response, and uplift models, we can build hundreds of these models on each specific action, on each specific segment, on each specific product or different marketing campaigns. And this is why it's better to have something in common and to write a pipeline in this field. So many steps would be the same, like feature engineering, when we have some raw features combination, aggregations, group by things, cleaning the data, again, missing values, encoding categorical features, feature scaling, feature dropping, drop correlations, outlier detection, some range, for example, the age couldn't be higher than, let's say, 150, right? Then we have train test methodology, train test validation in order to not overfit, undersampling, oversampling. Many things of it, they could be, let's say, standardized because everyone do the same things. Maybe I write it by my hands, but the other colleague do the same. He or she is writing by their hands. And we have many other steps that could be generalized, like feature selection process, hyperparameters optimization, metrics, saving the models, push it into GitHub, making documentation. This is also part of when we can create a special thing, a special script that will collect the document, for example, CRISP DM methodology, when we collect all the steps, and model calibration. How can we do that? We can easily think of some kind of pipeline. For sure, it's not a production code. It's not just for showcase you the methodology. Like we create in different classes, like feature engineering class. Then we have different function of feature engineering. Then feature cleaning, we have different functions for it. then modeling part, different functions. And then we can aggregate them into scikit-learn pipeline, or we can do ourselves pipeline. And there we will get some get metrics function, get charts, get the best model, get feature importance, get documentation, which is very important for us. And the most interesting thing here is that we can collect, we have a team of 5 people, right? And we can collect all the working methods from all the teams. And if they want to develop something else, they can also contribute into this library. And this is how we can optimize our time to market of machine learning models from 2 months at the beginning to 1 to 4 weeks. And here would be the special stage for target identification. It would be the longest part to understand what target would be, because as far as we know, in machine learning we have garbage in, garbage out rule. If the target is bad, then we cannot predict anything. What else can we optimize in this picture? For sure, we need to optimize A/B testing methodology, because manual A/B test it's not good, and we need to think about some experimentational system which will pull all your requests, all your pull or your models into the right way, and to understand if there's green light, that the model is working, or a red light, the model doesn't work. And monitoring pipeline, which is very important when you put the model into production, and you need to understand whether the model works good. Is everything okay? Doesn't model degrade in the time or not? And as a result, we deliver results 4 times faster. Suppose we have 1 model in 2 weeks, 2 models in 1 month, and if we have 5 data scientists, we have 10 models per month. And in general, feature store plus next best action could take 3 months for a feature store. It wouldn't be productionalized, for example. It would be just a sample from it. And 6 months for all this next best action, 50 models, plus optimization algorithm. And comparing to the usual process, which will take more than 2 years for these 50 models. Do we need these 50 models? I don't know. But in this case, we think about 50 models because basically we can think of every possible action. We can think of every possible business process in order to make our company more ML-driven or data-driven. And some key takeaways. Think about the business metrics, think about the business process, identify needs of the business, if they're business ready for this machine learning pipeline or not. Who knows? Draw machine learning system design, how we can optimize our models, how we can optimize our solutions. Are we ready for this or not yet? And unify the code, try to reuse different parts, and demonstrate your achievements to the business. Thank you.
Thank you. Thank you, Sergei, for the nice presentation, and thank you all for listening. So the next is the question session. So you can put your questions into the Slido, and we will have the QR code here. Yeah, once again, so those you want to join. And I have the first question, maybe. The first question is, you have mentioned that there is a lot of probability involved here, how successful a campaign is. How do you measure the accuracy of the trained models?
Yeah, it depends on the machine learning model, actually. The first metric that we optimize is machine learning metrics, precision, accuracy, recall, ROCAUC, and so forth. But then we think about the business metrics. For example, we calculated precision on some threshold, and then we need to think about how much money, basically, we earn with this model if it goes to production. And this is the main answer, basically.
Mm-hmm. And a similar question, but on the, let's say, larger scale, how can you measure how good the machine learning model performing in the real life? Can you measure if it performs better than just using simple marketing strategies?
Yeah, and this is the question about A/B testing. Basically, we want to compare our machine learning model with some simple marketing strategy, some basic communication with the customers. And if we compare this in the right way, in the right methodology, and if we see that the conversion rate or our target metric is much better for machine learning model than just communication with the communication with the customer, then for sure we succeed.
Please also use Slido to vote for the presentation. Remember, you can rate the presentation. It depends on what your preference on the content, on the speech, on the atmosphere, whatever. But then there is one more question. Can you recommend a good feature store?
Yeah, SQL. The answer is super simple. For sure, there are a lot of different solutions from AWS. Who else? So all cloud providers, Google Cloud, all of them have Azure for sure. They have this built-in thing. But you can do it by yourself. Just create a table, make a pivot table, like I mentioned before on the slide. Div group by, but not group by, pivot table. Then you just derive your all columns or your features into the columns, and you will have the columns and the huge table. And basically, it would be the feature store. Feature store, basically, it's a combination of one or several tables, and this is it. So it's not something very huge.
Thank you. The next one is how to know when it's time to improve your model.
It's a good question. Improving model, it's always time to improve your model, especially if you are building your model such a way of like automatization. We build a pipeline, build a framework, and we do always, and we apply this framework for all of these models. And for sure, it's a good time every time when we have capacity, for sure. And if we see that, for example, our initial metrics, let's say precision was 0.9. Doesn't matter the context, 0.9. We need to track and monitor our model into production, and we'll see that if our model degrades, if our precision is sliding down, then for sure we need to rerun to retrain the model or improve the model. Or maybe we have some new component, not new, I don't know, new ideas from the business. Hey, look at this thing. Let's implement this. For sure, we need to think about it. But first thing what I wanted to mention in my speech is develop a framework, develop a next best action framework, and based on that, for sure we can optimize the additional models and think about how to make it better.
Thank you. Next one, how much part explainability plays during the modeling process?
Yeah, it depends on the process. Some processes like credit scoring, they requires pretty much interpretability and explainability because different factors, because for example, someone came from the government can come to us and say, hey, why did you give the credit to this, why did you give the loan to this client? And we need to explain because of this factor, this factor, this factor. And usually in previous, I don't know how it is going right now, but they use logistic regression because it's easy, explainable, and understandable. Then, for example, if we are talking about in-person communications, in this case, explainability play a big role because the manager who will contact to the client, he or she, they would like to know why do we propose that client, why do we propose this product to this client. And this is why, yeah, it's important for this such a moments. But in other cases, I don't know, it doesn't matter. But for sure, you need to think about the business context.
Okay, thank you for the answer. And two more questions. Aren't too much data can blow up the feature store and slow down the whole process?
I had a deal with 2,000 columns and 100 million clients. So maybe the computations will be not right in a minute, but if we need to derive different processes. For example, we have a batch process. When we have a batch, we have, let's say, we have scoring once a month, and for this process, it doesn't matter. Let it be calculated. If we have a streaming process, for sure it matters. But if we derive only because at the beginning we just need to select the features, select the features, train the model, again select features. In this case, it's okay basically. For training process doesn't matter. For predicting in streaming process especially, it matters. But in predicting, you will take the special columns. You will not take the whole customer base and the whole feature space.
Yes, thank you. And the last question is from Sarki Roka. How much are the operating costs?
I don't know, sorry. For this question, I cannot answer.
Thank you. Big applause to Sergei.
Thank you.
Thank you very much for the presentation.